Hello, everyone. Hopefully lunch is settled in, the carbs are gone. It's going to be an exciting session. Let's get into some introductions. Where's the slides? There we go. So quick introductions. My name is Amit Kinha, for those who don't know. I'm the field CTO at DoiT. Prior to that, I was running FinOps globally for Citibank for a number of years. I've been involved with the foundation as well for a while. I started off as an ambassador, worked on the steering committee for Focus, and most recently I'm on the governing board. And I'll introduce himself.
Hello, everybody. I'm Ali. I am a FinOps engineer at the cybersecurity company Tenable. Been there for a little over 2 years. Before that, I was on the DevOps team at a SaaS ad tech based in San Francisco called LiveRamp, where I first got my feet wet in the FinOps space.
Great. So as a show of hands, how many people have heard about Snowflake or Databricks? Perfect. We're in the good room then. And how many of you are actually responsible in some way for managing the FinOps side for these data clouds? Great. So this session is really relevant because my journey also started off with in the data space where it was kind of handed over. Right? It was handed over to say, well, data cloud, public cloud, sounds similar, figure it out. And what I found, though, in the last couple of years, if I asked this question about data cloud, maybe half the hands would go up, especially around the responsibility. And as we know from the State of FinOps Foundation data especially, data cloud is getting bigger and bigger and bigger. And it's not just getting bigger in the sense that people are spending more, that's obvious, but it's also becoming a larger piece of the puzzle when we think about our cloud strategy, right? Snowflake and Databricks become, instead of a nice to have, they become fundamental parts of, especially with AI, how we're going to execute. And traditionally what happens is, with FinOps and data cloud has been similar to, again, the cloud costs keep rising on the data side, and someone decides, probably the CIO, that, someone needs to look at this. And FinOps seems like the place where this should land. And traditionally, what we end up doing is trying to apply the principles of, FinOps that we've learned, right? Crawl, walk, run, allocations, optimization, governance, you name it, and we try to retrofit it onto data cloud. And that can work, right? It can work to a certain degree, but what I find is that when it's not purpose-built with data cloud in mind, we start to see cracks on the edges. And that's what we're here to discuss. So what we want to go through is basically almost compare the differences between when you look at, say, a traditional CSP, AWS or GCP, and think about when we data clouds and what the differences are, and then finally get into a story from Tenable, from Ali, about how they were able to leverage a platform to help them with their Snowflake spend, and finally close with 5 dimensions you can take back to think about how to build your FinOps practice with data cloud as a first principle and not really bolt it on and the value you get from it. All right, so let's get into it. Traditionally, when we think about data cloud and infrastructure, on paper it seems very similar, right? You think about stuff like, tagging approaches. We have a great architecture team. We have beautiful dashboards that we use. We have the monthly or quarterly review with our engineers where we yell at them about cloud cost, and it works. But oftentimes I find that there's really specific differences, which means that data cloud needs to be purpose-built. And we're going to get into a couple of these, but they include things like what is actually driving the cost, right? Oftentimes we think about infrastructure as something you provision, the EC2 instance, the database, and there's a running cost around it. But in the data cloud, it's very different, right? It's all about executing. It might be the query at the query level, it might be the pipelines, the AI features, and similarly around the optimization levers of, if you take EC2 for example, traditionally we think about, well, let's try to right-size the EC2 instance, and then maybe we can purchase a commitment-based discount, a savings plan, a CUD, whatever. And on the data cloud side, it's a layer below, right? It's no longer just saying the warehouse can have a savings plan attached to it. You really have to think about how do we optimize the query? How do we tune the warehouses so the routing that's happening, the warehouse isn't triple the size and then doesn't go back to the normal size afterward? So let's get into some of these in a little bit more detail.
And Amit, let's focus in on one of the points that you just mentioned. In fact, let me tell you guys a story. A while back, I was trying to wrap my head around our company's absurdly fast, explosive growing Snowflake spend. I was doing some digging, what could we right-size, what could we optimize? And I somehow stumbled across a dashboard, just like the ones you guys saw at the conference during the booths yesterday and today. And I realized I was looking at a bunch of query-level optimizations, code changes that we could make that would save an absurd amount of money. You see, if we're looking at saving money, cost savings, the same way we look at saving money on AWS compute by only right-sizing, we're not looking at what the application is doing. And there's a ton of things in there that we can play around with. Imagine going to a car dealership and someone tells you you can buy this car, but you can't test drive it, you can't see what's inside of it. That car could have no engine, broken suspension. You don't know. The unit of optimization isn't the resource, it's the workload. And there's three key areas that we want to focus on. The first one is going to be query patterns. Are your transformations, are they full table scans or are they incremental? Are you only focusing in on the part of the table that you need for that query, or just pulling everything in and not really caring about it? Secondly, warehouse config. What does the auto suspend time look like? If something is meant to fail, let it fail. It doesn't need to run forever. And third of all, which me and Amit are both very excited about, is new cost vectors that a lot of people aren't tracking. We've heard a ton about AI during this conference. How much are we spending on Cortex AI functions that are billed per token? What about serverless tasks, dynamic tables? Most teams aren't even taking this spend into account. It's something that we want to focus on.
Yeah, and oftentimes when we think about these auxiliary spends, we think, well, that's not really our problem. We're the FinOps team. We give you the data, and we give you a report, and we tell you to look at the dashboard, and we've done our job, right? After all, we're not the experts in queries. And the reality is the data team is very different than the traditional infra team. Oftentimes, the data team may not even report into, say, the VP of infra, right? They might be under the VP of data or analytics. So oftentimes, when we think about, well, we've done our homework, we have our dashboards, we have our reports, these teams don't know about it, right? They've never looked at it because they're really focused on something completely different, right? They haven't been to your FinOps meetings. Instead, what they're focused on is pipeline speed, right? The query executions, the how to actually ingest large amounts of data, the analytics side of it, and not necessarily on cost. So much less, accountable for cost, but they haven't even considered it as a function before. Where they're really living in is in things like dbt, Airflow, Snowside, Jupyter notebooks, right? They're not in the space where we assume that because their practice is great and an infrastructure team understands cloud cost, this team should know it by default as well, right? So the fix to me is that we can't just make them care about it, right? The trope of engineers don't care about cloud costs. The lessons learned from should be, let's meet them where they are. Let's figure out their workflows. Let's figure out the data they actually can use to make these better decisions we keep talking about.
So this is where the gap shows up. Most traditional FinOps skills tend to be operational skills. Some of the stuff that we lightly talked about, like right-sizing, buying commitments, and just kind of best allocating spend to whatever team based on if we're having warehouses assigned to those whole teams. But now data cloud is changing the game because it's operational skills. We need to think about query tuning, warehouse config, workload routing, incremental processing. And unfortunately, this creates a two-pronged problem, where first of all, most FinOps people don't necessarily have data cloud skills. And at the same time, most of our data cloud or Snowflake engineers, they don't think about cost in the slightest until a huge anomaly shows up. That gap is where a ton of money disappears, and what we want to flatten as soon as possible. So let me give you some context on Tenable. We're a cybersecurity company. We've got about 40,000 customers globally. We're in all your big clouds, but pretty heavily on AWS, and growing in some of the smaller ones as well. However, for a company this large, it's a very lean FinOps team, 2 people. Just imagine the 2 of us managing all of this spend. And usage problems grew pretty fast. Another issue that we ran into a ton of issues, but let me try to get into how we actually went on addressing those. So there's 4 key issues that Tenable faced. We were in a lot of deep water about a little over a year ago. The first 3 of those problems all somewhat overlap. We have a ton of shared ownership in our warehouses and our databases, and this causes problems where, first of all, it's hard to know who owns what. Teams just see a shared cost. They think someone else will be responsible for it. Similar to that is cost anomalies. What I really hated is when an anomaly went off, we had some kind of automation so it would route to a Slack channel. But if 2 teams both shared a warehouse, Team A would assume Team B would handle that anomaly. Team B would assume Team A would handle that anomaly. Now the FinOps guy has to get involved. It's been a couple days. Costs are going up. A bunch of issues. And then thirdly, likewise, is it's very difficult to budget when things are being shared. You can see how these 3 issues all sort of combine. But the fourth issue, which was the hardest to wrap my head around, was just not knowing where the cost savings were. I could see that we were spending millions, but what do we focus in on? Where are the savings? Are they here? Are they there? If a ton of savings are coming from here, what is the effort required to take care of them? Not knowing was a huge problem. So we looked at problems, and we were seeing what we could do, but eventually my manager decided to go with Select to take a look at these issues. Select came in and did a few phenomenal things. First of all, a problem that I had, which really drew me up a wall with our previous FinOps provider, is they didn't have a way to ingest Snowflake tags. So imagine this. We'd spent a huge chunk of engineering time making sure everything was tagged in GitHub, all the warehouses, the databases, and our current FinOps tool couldn't even ingest those. So we were stuck at just manually allocating, based on a rough estimate, what each team would be taking up of each warehouse. It wasn't dynamic. It wasn't working. Secondly, like I mentioned with the cost spikes, we ran into issues where anomaly detection was problematic. But once we got that allocation issue fixed, then we could route if a team's partly warehouse or its queries were causing a bunch of money being lost, we could route it directly to that singular team Slack channel instead of a shared Slack channel where nobody really took any initiative at it at all until somebody higher up pinged a few people. But the thing I was most excited about is we had tailored cost savings insights. Imagine a dashboard where you see 8 categories, and in each of them, it tells you how much saving is there, and for each of those categories, the amount of effort required to get those savings. So of course, all of us here would focus on the highest impact, the least amount of effort. And lastly, which I was a little surprised by, was the tools for data engineers were quite good. They could see what their queries were running, how efficient they were, how much they costed. And what we'll talk about a little bit later is it surprised me just how much they enjoyed seeing that. So we made a bunch of optimizations. And the one that really stands out to me was the low-hanging fruit. Imagine this. With less than a day's worth of work, I saved $100,000 annual spend, just like that. How did this happen? Well, in one of those categories that I mentioned was permanent to transient tables. Select had flagged something around 121 tables that it believed should go from permanent status to transient. That would save us some money since we wouldn't have to pay for this fail-safe in case we needed to rebuild the tables. I thought it was pretty interesting. I looked into it. Some of those tables, which were ingest, were coming from tables that were already permanent. And this made no sense. We could rebuild those tables at any time based on these permanent ones, so why do these ones need to be permanent? Ran a few checks, talked to a few engineers, turned that off, and it's $100K in annual savings just like that. It's a nice resume flex, something to post on LinkedIn, but it felt good that there was low-hanging fruit that we could take care of. A few other examples was we noticed just with this one query optimization, 17K saved annually. This one here, 15K saved annually. Of course, I did have to go and confirm that these changes could be made. You can't just blindly turn stuff on. But it was pretty incredible seeing that the low-hanging fruit out there could be taken care of. And I would have no idea that it was out there if it wasn't for Select. That was cool. The second thing that I thought was even cooler was data engineers started to get involved in the cost process. I thought that data engineers never really cared about cost. They wanted to build things well, ship them fast. But when I started talking to them about, hey, we're seeing some of these queries that could be pruned, they logged into Select, and they started making their own changes. Because there's a sense of you don't want to be writing bad, inefficient code that costs a ton of money. When I just recommended, hey, could you work on this change? Can I help you with fixing this up? They would look at other problems here and overall just start writing code that saved us a ton more money. So there were 2 big shifts that happened. Observability, we know what's costing what, and a shift towards automation. So there's a saying that a picture speaks 1,000 words. As you can see here, over in June and July, our spend for Snowflake was pretty much at its peak. But we got aggressive with Select. We made as many changes as we could, starting with the low-hanging fruit. And you can see that our spend started to drastically go down, and it's more or less stable. That's all great. But what you can't see in this photo, which is my favorite part of it, is after June and July, our usage had still continued to grow. Yet it still remained flat, our spend, thanks to all the findings from Select.
Now, I feel like in the FinOps community, every year we come here, there's always
Actually, one more thing, if you can go back a slide.
Yeah.
I don't mean to flex too much, but just to remind you guys, we only had 2 people on our FinOps team. Just the 2 of us using Select were able to make this huge change. But go ahead.
No, to Ali's point exactly, right? Every year we come here, there's more complexity being added. There were scopes, now there's data cloud, there's tokenomics, obviously. And it just feels like there's more and more for us to do with the 2 engineers that we have. The data teams are growing, but the FinOps team are not necessarily being added headcount. And it feels almost like, there's another thing to learn. There's another group of people who don't care about cloud costs that we have to talk to. And I just want to say, on one hand, sure, but we've done this before already. We've done this first when we went from data centers to public cloud. And there's a lot of new paradigms that we had to learn, right? There was no savings plans for on-prem. There was no intelligent tiering on S3, whatever that meant at the time. Tagging was something that we started to learn, and then over time we got better at. And then there's complexities even in public cloud. When we think about Kubernetes, for example, all of a sudden you have this black box that's costing money. There's 4 different workloads on it, and we decided, well, we can solve it. We can use labels and namespaces as a proxy for tagging. We can think about proportionally spending and everything else. And so for me, data cloud is not this new paradigm, really. What it really is just another layer on top, right? There's another layer of nuance that you have to understand to get really effective FinOps practice up and running. Because again, you could just continue the dashboards, you could continue the monthly reports, but you're not going to see the results. We're going to go back to the same place we were, which is data engineers, right, don't care about cloud cost. And when you actually talk to them, they're like, well, I have no idea what you're even talking about. I thought this was just managed internally by somebody. And so what we want to do is basically walk through 5 different dimensions of what a FinOps practice looks like that might be bolted on to data cloud and the pitfalls, and then what it would look like if it's purpose-built instead. And across these 5 dimensions, basically, they might be linear, it may feel linear, but to me, they really are, it's almost like crawl, walk, run all over again. Right? It doesn't have to be that you have to go from 0 to 1, but you really want to look at these dimensions from a where are we perspective. So the first one really is the lifeblood of all FinOps is visibility, right? And for me, bolted on FinOps would mean that we're doing more of the same that we did before, right? We tag the warehouses, we tag the Snowflake accounts, and we get you pipe them into our dashboard, we send an email to the data team, they probably right-click archive or worse, junk mail, never talk to you again. But you're really missing the why, right? The warehouse might be costing X money and it's increasing, but you don't really understand why, and your data team engineers also are like, what do you want me to do with this cost? And for me, purpose-built goes a layer deeper. Right? We start thinking about attributing spend, not just at the warehouse level, but let's start thinking about specifics, right? The queries that are running, especially with agentic AI, where an agent could be calling your Snowflake database 100 times a day. All of a sudden, you want to understand where is this originating from. Same thing with pipelines, right? You have a lot of data that's being ingress and egressed, and you want to understand, is this the right approach? Yeah, similarly with users, teams, features, you name it. And then when it comes to these advanced features that are sometimes untaggable, we don't want to just stop by saying, well, it's untaggable, just divide by proportionally or number of users. You can actually proportionally attribute that cost directly to the teams downstream. And I think the value really you get out of this is that the data engineers are no longer looking at a number and feeling almost helpless. They can see the queries, right? They can understand, oh, the results of the change that I made is exactly resulting in double the warehouse cost because this one query is running 4 times a day, and even though the data is refreshed twice a day, right? And all of a sudden, these level optimizations where the savings really are. So the question you want to ask yourself is, can I tell a data engineer exactly which of their queries cost the most last week, and more importantly, why?
The second vector we want to look at is stakeholder reach. When you're bolted on, most likely you have the FinOps team being the only person who's reviewing a team's spend, their dashboard. Maybe there's some quarterly meetings, maybe there's some monthly check-ins, but it tends to be the FinOps team in charge of all of that. Any emails that get sent get pretty much ignored. The only time something really happens is following a big trend up or a cost anomaly where people dig in on it. Once that cost goes down 80%, they kind of kick things to later, we'll look into this, later we'll check in on this, and it never really happens. What we want is for cost to be a developmental consideration, not an audit finding. I mean, think about the cultural signal. if your team is known for putting cost ahead and not putting it as someone else's problem, if they're putting cost as someone else's problem and not their own, they're bolted on. At Tenable, the question I asked was, do the people who are driving 80% of our cloud spend know they're the ones spending that much? Can they see immediately where that money is going towards? We want this to map back to the FinOps framework, where the engineers are the stakeholders. They're the ones who need the tools to quickly understand what their queries are running, how often they're running, and what their cost impact is. If we can put those tools in their hands, we're a million times better off than sending it to some IT manager who kind of conveys the message and it gets lost in that in-between.
Now, if you're able to do the first two things, right, you get the visibility at a level that we're comfortable with, so we can investigate and try to optimize. The stakeholders are getting bought in. The next obvious question then is, OK, what do we do then? Right, we have the data. It shows us we're inefficient. Now what? And for me, the optimization plus automation, I know automation scares a lot of folks, especially if you're in the regulatory industry. After all, no one wants to be blaming a third-party SaaS tool for bringing down production because they were over-optimized. But for me, the bolted-on version is more of the same, where we have manual reviews once a week. There's a cost spike that happens. There's a Jira ticket that gets created, goes to the backlog, and the product manager never prioritizes it. And we say, someone should fix this. But eventually, not yet. And purpose-built for me is that the reason for that is often that it is a lot of work, right? There's a lot of work that goes into tuning a warehouse. It might be happening every week. And what you don't want to do is just move the burden along to your engineers and say, figure it out. I think there's a better way, where automation for a lot of this low-hanging, low-risk fruit can yield a lot of results which get you buy-in. So things like continuous automated optimization with guardrails, things like warehouse tuning, right? You have a 2XL warehouse in Snowflake. And sure, an engineer could look at it for a week and say, yeah, I think this can be a medium. And as soon as it goes to a large, it never comes back down again. Or similarly, right-sizing, idle cleanup, things that we got used to doing on the public cloud side, we should absolutely be doing on the data cloud, but do it in an automated fashion. What you want to do is leave your engineers, especially the data engineers, use them for the really complex things that you don't want to use automations for. And this includes things like looking at queries, right? Understanding which, which data should be flowing in, where the joins are. Sorry, excuse me. The complexity of the things is where you want the engineers' time focused on, and not on these things that should be happening almost daily, continuously. So the question you want to ask yourself is, if a warehouse is oversized right now, right? Say again, it's a 2XL, and you think it should be a medium. How long is it before it gets fixed? Not notified to the engineering team and then they look at it, but how long would it take? And personally at Citi, this would be a couple of months process at best. It'd be a lot of conviction that'd be needed to say, yeah, but because again, data engineers care about performance more than anything else and reliability. And the scary thing is always, even if it is non-production, it's like, yeah, if I make this change, if it goes down, what do I do instead? Instead, if you leave, you start small and you look at non-prod environments, ephemeral environments, testing environments, you name it, and you start to think about these things that should be automated. Maybe it happens once a week. You run a job that can tell you these are over-provisioned, and you have a PR that's automatically created, and still the data engineers sign off on it, but they're not doing the investigation for you, and neither are you. You're automating these things away. And I think this is a way you can actually get to scale where, what Ali's mentioning isn't taking up Ali's time for, 5 days a week. Instead, it's one thing that you write, and then it runs on its own.
So vector 4 is speed of feedback. And this is by far one of my favorite vectors to look at. I mentioned earlier just the huge frustration I have when a cost anomaly comes in. It just sits in our email inbox or a Slack channel for ages, and no one really jumps on it until one of the senior managers jumps in, tags somebody in the thread. When you're bolted on, you have anomalies that don't go answered for days. You also have monthly or quarterly cost reviews. I can remember a bunch of people looking at a presentation board and realizing, whoa, over the last 90 days, this team has been trending really high. Where did that come from? Why do we have to attack that 90 days later? Think about all the cash that's been burned since then. Additionally, now you have to send engineers to go backwards in time to things they worked on before. They're wasting their own mental compute trying to remember how did this thing run. Then when they finish that problem, they have to go back to work they were previously on. We want something purpose-built with pretty much near real-time anomaly detection. We want daily monitors for teams, immediate alerts for cost spikes. One of the questions that I love to ask is, let's say an engineer deploys a dbt model, and something gets messed up, doesn't work right, and it ends up adding 30% to that team's Snowflake spend. How long would it take for that engineer to realize that happened? And would he know on his own, or would someone else have to ping him and message him to let him know this is happening? Data center was quarterly reporting. Cloud was weekly. Data cloud needs to be as close to real time as possible.
And then finally, if you're able to do these things, right, you have the visibility, you get the stakeholders, you have the optimization that's running somewhat autonomously, and you're getting buy-in. Right? A lot of these things aren't that new in FinOps. Right? We've been talking about shifting left forever. We've been talking about data that is actually useful for the right person at the right time to make the better decisions. Right? It's really a cultural practice. And for me, the last dimension really brings it home is that the organizational model. And I'm not talking about the data team and the FinOps team merging or the org chart. What I mean is more fundamental, which is at the end of the day, what you want is your data engineers and the data practice to feel accountable for the costs they're spending, right? And not just on paper where they say, yeah, we own it, we'll look at it, but they really feel somewhat accountable for it. And for me, bolted on is a place where, at least with Data Cloud, the FinOps team still owns it, right? They still own it in the sense that, sure, it might not be their budget, but they're still responsible for pushing, for going to a meeting, yelling at the engineers to say, you got to do something, getting buy-in. And the alternative to me is that it doesn't have to be that way. The FinOps team really provides two really important things. They provide the framework, right? They provide the understanding of crawl, walk, run, how to actually access this data in real time, how to get alerts set up properly so the data is not going to some engineer who's not even looking at it, but maybe there's a support team that should be getting it. And eventually, the goal is the data teams own their spend. And not on paper, but they actually feel responsible for it. It's accountability that lives in their OKRs. When they're doing architectures for new ML trainings, they're thinking about it because they have access to two critical things. They have access to the data, and they have access to the tools to actually think about, well, what happens if I change the query around? What happens if I actually change the warehouse? They're able to test in real time and see the cost benefit without having to rely on the monthly report that comes out normally. And to me, this is the end of the maturity endpoint. Like if you can do all the things we're describing, the end goal is that there's accountability, right? Your team is able to work with the engineers and understand what is their workflows, how do we embed ourselves in there, and not necessarily just giving them, here's a dashboard, here's a report, and here's the email you get, good luck. You actually have to sit down and work with them on it. So the question you want to ask yourself here is, it sounds like silly, but truly, does the data team feel ownership of their cloud costs? Again, not on paper, or is it still someone else's problem? Now, the 5 dimensions we described, again, it's not linear in that, of course, the holy grail is accountability. But across visibility, reach, automation, speed, and the organizational model I'm describing, you want to ask yourself, where are we today? Right? For example, most people I talk to from DoiT, when we're talking to our customers, are still on the visibility side. They've tagged the warehouses, but the engineers don't know queries. Once in a while, they'll look at a query when there's a big FinOps moment, when the spend is $1 million or something, and they have to look. But it's always it's very reactionary, and it's never proactive. And so if you're able to score yourself in these dimensions and start thinking about, yeah, we had our engineers, we did a big, for example, in automation, we had a big push, right? The CIO said we got to lower the Snowflake cost. We spent a week and a half, and we got it down. And 2 months later, it's back to where it was again until this happens again and again. That's where automation can come in. Similarly, on the speed or feedback, being able to actually have metrics around, there was a recommendation that if we enacted that was safe, it could save us 40%. Why did it take 4 weeks? Why not 3 weeks? Why not 2 weeks? So starting the crawl, walk, run across these 5 dimensions in a way that you're able to actually make movement across is really beneficial. So for things you can actually take back home, a little homework for next week is, to me, it's not rocket science. It's pretty straightforward. The first one is really try to map your cost, not at the warehouse level, but really at the query level, right? And if you don't have access to that, even if you go to the data engineering team, sit down with them, try to understand, well, how would I actually see this, right? it's your first step because a lot of the times the query level is where a lot of the waste is happening. And I'll give you an example. Imagine a data warehouse that is at 100% utilization. When we think about an EC2 instance, for example, you're like, that's a good thing, right? We are right-sized, exactly what it is. But if you don't look at the query level on a, say, Snowflake, what will happen is, sure, it might be at 100%, but that's because the queries are so unoptimized, you're overspending because the utilization is high, but the ROI is really low there, right? The second one then is, naturally, is in order to do this, what you need to do is actually talk to your data team. And not talk to them in a one-off monthly meeting where you say, hey, here's the tools, good luck, but sit down with them, right? Really understand their workflow. What is the things they're prioritizing? How do they actually work, right? And then you have to figure out where does cost visibility fit into their workflows, right? Maybe they don't want a dashboard. Maybe they want a CLI that can automatically create a PR. Who knows? But the goal is basically you want to embed this data as close to where they're actually working as possible. So it's not this thing that they have to review afterward. It can be part of their day-to-day CI/CD, for example. And then finally, you want to start automating, right? And again, it's a scary word, but I'm talking about things like auto-suspending tuning, right? Idle cleanup, shutting off the lights on the weekend. The warehouses that are sitting idle for the POC that ran by the interns, well, the interns left, it's still running. How do you actually do this so you're not doing it manually? And try to figure out what tooling can we have to actually get this done. And I feel like number 3 is the most important one because what you get out of it is this idea of confidence, not only from your leadership, but also from the teams on data who start to see the benefits of this, right? And all of a sudden, the trope of engineers don't care about cloud costs, to me, it's really silly. I'm an engineer as well. It's just we never had the right data or the tools to actually care about it or do anything about it. So being able to give them the agency to say, I don't need you to spend 40% of your time looking at these charts and dashboards, but we've done all the low-hanging fruit. Help me figure out this optimization for a query is where we want to be at the end of the day. With that, I want to thank you, and we have plenty of time for questions. Yeah.
Yeah, if you've got any questions, I've got a nice toy here to throw to you with a microphone in. Any questions? Yeah.
Great presentation. Clarity in terms of the query visibility in Snowflake, for example, are you saying you set it up in such a way that they can see their query costs right in the Snowflake interface, or are you talking about a separate report? Like how do you surface the query costs to your users?
Ali, do you want to take that one? How do you do it Tenable?
So I've talked to some of the guys at Select, and this is a very difficult thing to do. But I mentioned in those 8 cost categories they have, one of them is query optimizations that can be made. What I noticed when I was looking through them is a large chunk of the time, the reason why the query is so poor is because it's pulling in way more data than it actually needs in order to get the process that it needs to get done. That's generally the most common issue that I found. And again, I was targeting mostly the low-hanging fruit, the low-impact ones. When I click that, it can show me the lines of code and the query that's actually being ran. I'll go find that in GitHub, and I'll make that change. And all of that is done from Select. When you click a button, you can see where it is in GitHub and go from there.
Got it. So it's just separate. It's not within the Snowflake.
Not in the Snowflake's interface. Select has its own interface, which is pretty good. We prefer to use Select's interface just because they also have another tool called the usage groups, where we could basically create groups that have multiple different tags, different attributions, to kind of group together our different teams at Tenable. So we're already in this Select UI, and then from there, we'll just already go into what savings we can find.
Brilliant. Another question over there? I won't try and throw it from that far.
Ooh.
Good catch.
How do you guys balance kind of the daily cost, the look at daily cost versus credit burn down? From an optimization standpoint, like we're kind of in kind of the midpoint of the maturity scale, where we've got some visibility and some optimization tools in place, but our teams kind of look at, well, we've got this many credits to burn because we bought, whatever, $1 million of credits. Right now, our credit burn looks like we're totally fine. Why am I going to waste time on this optimization? How do you guys balance that?
Yeah, it's an interesting question that also exists in public cloud, right? You sign an EDP or PPA, and on one hand, you say, well, we got 15 million, it's okay. And I find similar to tokens, right, that if you're able to actually minimize the cost for a lot of the workloads, what I found it traditionally is that there's more workloads people can think of because they're not thinking, well, Snowflake is very expensive. We're going to do everything on-prem. They start to realize, wait a minute, not only do we get the visibility at per, say, workload or query, we want to move more things over. So, it's one of those things that, yeah, you don't want to be too much under, but at the same time, I think optimization leads towards more usage than you'd intended because the cost at the unit level is lower at the workload level and not necessarily, say, warehouses.
Sorry, if I can, one more question. So you guys mentioned a little bit about Cortex and other like non-compute costs. How are you planning to attack that? Because that's definitely something I'm dealing with my teams as well. Is the Cortex and other AI usages
Right.
on the exponential path? How are you guys handling that, either within your tooling or within your just overall organization?
I'm a little embarrassed to say this, but at Tenable, because we've had such a huge issue trying to tackle our AI costs, which as you guys have all seen, it's a reoccurring theme, this entire FinOps X, we've actually disabled Cortex temporarily in Snowflake because we're already trying to deal with this whole Bedrock issue. We don't want to add Cortex on top of that. So I'm interested to know the answer to that question too, Amit. If you would tell us if we enabled Cortex, what would you recommend in that case?
Yeah, it's funny. When you think about the consolidation of, so you're using Cortex, you have Bedrock, you have some cloud plans, someone's still using their ChatGPT personalized version. To me, Cortex is one of those things that what you want to solve is the tokenomics at a core level and not necessarily provider by provider level. Right? Because otherwise, what you end up getting is it's almost like building for AWS, and then you build completely different FinOps practice for GCP. Right? So the fundamentals of the value that we've been talking all day today about tokenomics, how do we actually measure, it's not an atomic unit, right? We have to look at inbound, we have to look at the context, everything else. You want to solve that from a first principles and then apply to Cortex versus starting there. Because what you'll find is that the fidelity of data might not be the same in Bedrock as you're getting in Cortex, as you're getting directly from, say, a provider like OpenAI.
Hey everyone, producer Andrew here. Thanks for watching. Check out the rest of our channel for more FinOps content. Like, subscribe, and leave questions and comments for our speakers. We appreciate your support.